Okay, so we have 15, 16. Okay, any more? Donovan. Gregory. 17. Okay, so 31, another minute or two. Just wait for people to get in. Tim. Okay. Okay. Okay, let's get started. First of all, I figured out why I wasn't able to do the connection between my local computer and the GitHub account. The second way, a different way, right? And I figured it out. It was because GitHub changed the main branch from master branch to main branch. Okay, that's why it didn't work. And they started that idea, they started that change in October. Okay, so I'm going to show you. It really pissed me off. I'm going to show you why. Okay, you've already figured out why, but so I did this research and find it out. Okay, it's because it turns out that is from the office of long overdue. Another service dropped the divisive master terminology from its technology. That's why. So it's GitHub. This time it's GitHub, and the new nomenclature will shift from master branch to main branch starting October. The reason was that change should be obvious, of course, but for those that aren't sure, is to rid the company of any holdover references to slavery and replace them with terms of inclusion that cannot be misconstrued. The change across the tech landscape should have occurred long ago, but at least it's finally happening. Starting October 1st, that's like 2 weeks ago. And all master branches will be called a main branch. That's why a week ago when I tried to connect to master branch, it failed. I didn't know they made this change. That's why it didn't work. And took me a little while and find out that was why. So I tried to make a YouTube video to show you, but I thought it was too hard to explain. So I'm going to explain to you now how basically the same thing. You just have to change the name from master to main, and then you'll be okay. Okay, I'm going to show you today how to do that. Now, the first project was due a couple weeks ago, right? So, so I finished the grading, and I was very, very disappointed because 8 people didn't hand in, okay, out of 26. So 8 people didn't hand in anything. And those who did hand in, a few of you didn't do anything, basically hand in a shell. Okay. So that's not good because we only have one CSE 248 scheduled for next semester. I don't want just you guys make up the whole class. Okay. A few of you did a great job. Exactly I wanted. Okay, so there are some small issues I'm going to talk about, but but overall, a few of you are very serious, did a great job. That's what I expected because at this stage, I thought you should be motivated and do it and do a decent job, but that's not the case. So, so I guess I'm going to have to give you a little bit more time. Those of you who didn't do anything, um, so that we will stay around and see if you can pass the course. Do you guys have that enthusiasm, that motivation to actually do it, or I'm just wasting my time? Are you going to do it if I give you a little bit more time? I did a template, I think, right? Some of you guys followed it. Some even said that that's like now the job becomes like a filling blank, okay, because the whole framework is already there. But still, many of you didn't do it, didn't hand anything. So kind of that's very disappointing, really, right? I tried to give you some extra time, give you, some extra pointers, did a demonstration, even though I didn't finish the whole thing, but I don't think you expected me to finish the whole thing. But I gave you the whole template, the framework. You could still fill in blanks. Okay, so I'm going to talk about a few things that I saw that I hope you will pay attention to it. I wrote a small. Hold on. No, I wrote some small issues. Okay. Can you read my screen? Can you read my screen? Yes. Right. It's not too small, right? You can read it. Okay. The first thing is no GUI. Okay. Don't hand me in a application, a complete application. That's not what I want. That's not the purpose of this assignment. Okay, don't think you are in 218 or 148. You just hand in the product and it shows it works. That's not the goal. That's not the purpose at all. The whole goal is really evidence-based evaluation discussion of the data structures you choose for the project. That's the goal. Okay, it's not you finish the product using array list, because that's not. I know it will work if you use array list. You don't have to demonstrate that, right? But that's not the goal. Don't just hand in something, it works, and have even have Java facts or GUI and the scene builder. That's not the goal. Okay, you should not give me that. So as the beauty is only skin deep. I don't care the beauty. You may spend a lot of time trying to build a scene builder application, okay, to show that the program works. Okay, that's you get zero. Okay, you get a zero on that because that's not the goal. You got it? I emphasize over and over again, it's about data structure evaluation. Okay, is specifically, I said, is evidence-based. Yes, remember that? That's why I said you have to generate the data to test your data structure, test your ideas, right? So that's the goal. It's not how beautiful it looks like. It doesn't matter what kind of GUI. I said no GUI is needed. You don't even need to have a comprehensive product. That's not the goal. Okay, so so hence no JavaX, no scene builder needed. Okay, you got it. Okay, that's the one thing. I saw you people doing that, then overlook the main goal. The main goal is evidence-based discussion to know the project. You have to figure out what's the best data structures for the three types of data sets, right? Profile, user profile, or user account, trails, and history, right? History of each user. So that's the purpose. Okay, you okay with that?
So the only time we would show FX for this project is if we use Java to show a graph, right?
Well, you don't even, I said you don't even have to hand in graph. If you want to, that's fine. The main goal is to decide on what's the best data structures to use for the three data types, right? You can do settle whether you're going to use linked list, array list, arrays, queues, stacks, and or tree map or hash map, hash set, tree map, tree sets, right? Based on the requirement of the project. So those are things you have to contemplate. You say, okay, what you're going to use. Okay, now how to write a discussion. Okay, that's something that I realized that maybe it's not obvious to you. Okay, which I realized later. So I wrote down a few things I think will make a perfect discussion. Okay, I know most of you didn't do it, or many of you didn't do it, but this is something you should know, not even if not now, but down the road in the future, how to write a discussion in, say, computer science or any kind of a research paper. Okay, if you've done a research paper, you should know about this. Then I realize probably you never did. So now I'm going to introduce that to you. Okay, first part of the discussion is introduction. Okay. And then what's the goal? What are choices available? So you have all the data structures available, right? Some are obviously not appropriate. So you need to eliminate those, right? Because when you test the right data structure, some you don't need to worry about it because they are
Brian
obviously
mute.
not the right ones, right?
Brian mute.
So you're gonna have to eliminate those. So you just only list the ones that are plausible. Okay, the ones that are reasonable. Okay, so so you have to eliminate the obvious ones. Then only those ones that you're not sure about, right? Because nobody is sure. So, for example, you can eliminate the hash anything, hash map, hash set, because they are not don't meet the requirement, right? Because they don't keep um, they the program has to be built for a given size, like a number of users, number of history entries, and then the number of trails, right? We already said that's not known. Those are unknown. So those can be eliminated right away, right? And also, if you're talking about a history, I also mentioned you have to know the order when those things are conducted, right? Or those hikes are conducted or carried out. So you want to keep the order. Then obviously that will already allow you to eliminate a bunch of things, right? Because you need to keep the order, correct? Does it make sense? So those you can just eliminate right away. So you don't even have to discuss those, right? Because anybody has any clue would know that those are not the ones you need to be tested. Okay, we eliminate them. Okay, only ones remain say tree set and tree map and arrays and stuff, right? Then you can have some discussion, introduction, right? Talking about why some are not appropriate, like array is not appropriate because of size limit and so on and so forth. And then you're going to propose some hypotheses. Okay, so you will say, okay, I believe um, tree map, tree set are better choice. Okay, and better choice than linked list, because linked list is open, right? You can add as many as you like later, right? You can expand, in other words. So that is a choice, correct? That is a choice. Or you can say, oh, okay, it is a choice, but we know from data structures, linked list do searching is n. We already know that, right? So you can even eliminate that, okay? Or one or two students decided that linked list is the way to go, okay? So what they did was they take the linked list as the main storage, and then they will take everything out from the linked list to put it into an array, okay, to actually retrieve every item from the linked list, put into an array, and then do a sorting. Once you sort it, then you do binary search. Okay, is this something you think is a good idea? You take everything from linked list, you put into array, and then you sort it every time. Because every time when you insert a new trail or new user or new history, you have to put into the linked list first, right? Because that's your primary. And then you're going to have to retrieve everything, put into the array, and sort it again, right? You have to sort it again. So every time you put a new entry into new trail or new user or new history, you have to sort it again. You have to do the whole thing over again. Okay, for what? To to get that login, because binary search gives you login, right? Okay, so you may discuss that, or you may say, all right, maybe this is a solution, fine, but test it, right? You don't have to test it. So you're gonna have to decide some kind of hypothesis. So when you do research papers, it's always like that. This is just um, like a recipe, okay? For you write any research paper, make any argument, you use this recipe, okay? Now, once you have a hypothesis, then you're going to discuss how you're going to test it, how you're going to test the hypothesis, right? And then you can write your approaches, your methods, and basically your methodology, right? Your methodology. Okay, I can put this in as method. methodology. Okay, so that's how you're going to test it. Okay, using API obviously, and then you're going to generate the data. You're going to generate your dummy data, test it. Correct? Okay, and how many or how big a dummy data you can set? You're going to test it. You can say, okay, I'm going to test it with 10,000, right? 20,000, 30,000, 40,000, 50,000, and so on and so forth, right? And some students use like a test with 1, 2, 3, 4, 5 dummy data sets, like one data set, one trail, and 2 trails, 3 and 4 and 5. Those are too small to be meaningful, right? You won't see much difference because even if you do sequential, it's only 5, right? You go to sequential search, it's 5. When you do binary, it's 3, right? When data set is so small, right? Binary is 3 and sequential is 5. So the difference is so minimum, right? So you won't really see much difference. That's why the data set has to be big enough to see a difference. Can you see? Can you see the point? Right? You don't want like a 5 data sets. That's too small because you won't even be able to tell you anything meaningful. The sample size is too small. That's why that's the part you're going to explain in your approaches and methods or methodology part. Yes? How much data and how, and then you're going to talk about your results. Okay, from your methodology. What are the results? What are the data sets you get out from this? Whether you're going to present it in some kind of a graph or table or just text file, it doesn't matter. Okay, that's just the results. Once you have results, you're going to discuss your results. And finally, you draw your conclusions. So that's just general recipe for any kind of a research paper, any kind of um, discussion or try to make an argument. Okay, you may not have well partitioned like 6 parts, but you should have such, say, paragraphs maybe. Okay, so first paragraph, you may not want to have a subtitle for that paragraph. You just discuss the available ones, a few sentences, and then the hypothesis is, I believe that tree map or tree set is the way to go, is more efficient based on what we learn about the data structure, right? The internal mechanism. Okay, then just need to have to test it, right? Or you can say one hypothesis is for username, I may want to use a tree map because the tree map means there's a key value pair, right? So the username is a key, and then the rest, password, the profile picture, and all those are the value, right? They make an object out of this as a value. Okay, so that might be your hypothesis. Okay, for user profiles, I'm going to use a tree map. Okay, now for trails, I decided I want to use a tree set, maybe. Whatever you decide to do, right? You have to kind of conclude that when you do the discussion introduction, right? So that is your second paragraph. That's your hypothesis. Third one is you talk about methodology, how you're going to test it. Okay, then the fourth one, you have your data sets for each data structure. You know, what is for the same data sets and what the time you took for each data structure. So you can draw a conclusion, right? Then you can discuss in detail why there's such a thing, why the data comes out like this, right? Then you try to put in your explanation, why data come out like this, why this is faster, why this is slower, and okay. And then finally, just your conclusion is okay, this is what I'm going to use for this. This is what I'm going to use for user profile. This is data structure I'm going to use for trail. This is the one I'm going to use for history. So that's how you do discussion. Does it make sense to you? Okay, so in the future, you will get into the situation that people want to write your research paper, an essay, to make an argument. Okay, like you have something to publish, and you say you go to a conference, right? Computer science conference, and you try to present some of your research, and that's the recipe you have to follow. Okay, that's everybody follows. It's just like you. Everybody follows the recipe. All right. Good. Okay. So and that part, the methodology is spelled wrong. So that part, that's the main goal, the main focus of this project. Okay, not finish the product with everything, and there's no discussion why you pick the data structure. Right? That's not what I want. So you cannot just use an array list, an array for everything. It works. Yeah, okay, it works, but that's not the point. I know you can do that because you can already do that in 148. It'll be too easy for this course, right? It's not. It just works. It's like it works. It works the way you have to focus on the things I want you to do, basically, to justify the data structure. All right. And now I look at some of the results, right? And it turns out that the results are very, it's not a very consistent when you present it. In other words, when you increase the sample size, say you choose the tree set, say, or tree map, right? And when you increase the sample size, and then the amount of time it took varies. So say 10,000 took 5 nanosecond. I just give a number, right? Say 10,000 to 5 nanosecond, and 7,000 took 3 nanosecond. That doesn't make sense, right? That doesn't make sense. You increase the complexity, increase the problem size, you take less time. That doesn't make no sense because the best with big O is 1, correct? Big O 1 means it should be the same amount of time, regardless of the problem size, right? But if there's no big O, that is, when you increase the problem size, the amount of time it takes to process data is less. You realize that? There's no such thing. When you increase the problem size, it takes less time to do the operation. There's no such thing. The best we could come up with is 1. That means the same amount of time. Yes? So something must be wrong, right? That must be wrong. How is that possible? Right? So it turns out that if you do one search or one insertion, especially when you do one search, you generate random data, you do one search, that could happen. Because remember there's something called a best case scenario? What if the value you're looking for is right there, the first try, first comparison, you found it? Right? Say you have an array, right? The binary search average case scenario is log n, correct? Right? Sequential search is n, correct? Sequential search, yes? Say you have an array, right? But the best case scenario is if the value you're looking for is right as the first element in the array. One comparison, you found it, even when you do sequential. That's the best case scenario. Right? So it doesn't matter how big the array is, 1 million, 2 million, 100 million. But if it's the first one, sequential search will get you in one shot. But so when you increase the array size, the amount of time will take less than binary search even. Yes? Because a median will take 20 comparisons. But sequential search best case scenario is one. You find it in one shot. So that means when you do this kind of um, analysis, you have to generate a bunch of random values to test. You try to avoid the best case scenario and also avoid the worst case scenario, correct? Because that's simulating the real life. When people try to log in, the username is not best case scenario, it's not worst case scenario, it's an average case scenario, right? So you're gonna have to generate a lot of usernames and user accounts to test it out. Then you get an average value. Then that's the average case scenario. So we only look for average case scenario, not just one test. Does that make sense? So when you look at your graph or table or whatever, you should pretty consistent. If it's flat, it's one, then it should be flat. You should not like a big fluctuation, like when you increase the problem size, the amount of time it took much less. That makes no sense. Doesn't intuitively, it doesn't make sense, right? Okay, Jaleo, you have a question?
Yes, I had a question. So going back to that about the search,
Mhm,
when you increase the amount of times,
mhm,
it's good to do, for example, so when you insert it for the first time 1,000, it's good to
mhm.
search in the middle. So like you search for the middle profile, for example, instead of the first one or the last one.
Well, those profiles are all random, right? How do you know which one's the middle?
Well, the in the way you generate it, you will determine.
No, you're gonna generate random data. You don't want to generate a sequential or any kind of pattern. You don't want any pattern because right when user come in to create a user account, they're all random, right?
Hmm.
You decide a user will decide what username to use as a key, right? You cannot make them starting with A and B and C. You cannot order them. So there's no middle. When your data is in the data structure, there's no middle. You don't know what username is in the middle,
Okay.
right? Make sense? Okay, so that's the main thing. Okay, all right. So very few people wrote discussion at all, which is the main goal of the project. Remember, the project is deciding on the right data structure to use. Yes, so that's the goal. I even wrote when I wrote the template. I even said there's a section called a file called discussion and conclusions, right? So of the people who submitted, more than half didn't do anything, didn't even talk about, just went ahead and implement the whole application. Some just gave me a shell, of course, with nothing in it. There's a hello world. That's not good. Don't give me hello world, right? This is your last semester. You don't write hello world. Okay, so you need an average case scenario. So lots of transactions are needed in value evaluations to avoid the best case and the worst case scenario. Okay, so once you have that, once you have a sufficient sample size, then your graph or your table will look consistent. Whether it's 1 or this n or log n, then the graph will be meaningful. Otherwise, it's all fluctuating like crazy. Yes? Because it's all fluctuation between worst case scenario and the best case scenario. And just to pick one, it could be all biased. So we should avoid that. Okay, good. Yeah, Jaleel, okay, go ahead.
Just to understand, when doing the search, it's best to just like do a random search of a random profile, for example, instead of like pick a specific
Right.
one.
The profile we put in has to be random into the data structure. Say you use a linked list. So
Mhm.
you're going to generate, or not linked list, you use a hash map, say, or tree map. So you're going to put a bunch of a random 10,000, 20,000, 30,000, so on and so forth, into the tree map, and then you're gonna search for, say, minimum 100 of random user profile. You don't do it manually, of course. You just write code. You put an argument in there. I want to test 100 random username or 1,000. It's like 10% of your usernames of the data size, and then average it out. So it's a pretty daunting project. But if you're focusing just on assessment, not on GUI, not on trying to finish the whole project like a coherent project, it's actually not bad. It's not that bad. Plus, we didn't have any other work. That's the only work you did, right? You were asked to do. Yeah. So okay. So that's what I was looking for.
Wait, so Professor, with what you're talking about, I had that issue with generating.
Right, I saw yours. Yes.
With generating the initial data structures though as well. That's kind of throwing me off. So even as dealing with 10,000, 20,000, and increasing the problem size, it still didn't look normal.
No, it's just not just putting the random. Well, first of all, when you generate the data, dummy data to put in the data structure, you have to make sure the data are random. So for example, if you use a tree map, then the keys should be random, right? They should be randomized before they put it inside the data structure. When you don't write the emit methods, so you generate the data in sequential way. Avoid that, right? Right? Because if you put it in the sequential way, what happens is then the tree will be biased. Okay, so avoid that. And then most importantly is when you do search, you have to search random user profiles. Right? So you have to take all the profile and randomize it and get 10% of the original data, the problem size, and do search.
Yeah, I think that's where I went wrong too, because I did.
I knew that. I saw that.
I was searching for randoms, but just one at a time, I guess, and then that
one at a
throws me.
time is fine, but you have to do many times to average
Right.
out. But
that
you
makes
did
sense.
one, so I realized that's why it happened to you and a few other people. So, but you do see that fluctuation, like your curve.
So yeah, so with generating the structures, then even so, what do you mean by not making it biased? So you would like maybe generate an array first of data and then take that array and put it into another data set randomly?
Well, that's a possibility if that's how you want to do it, right? Because we are not testing how to randomize data. We don't care how you randomize data as long as you randomize it, right? Because that's not the point of this project.
So just the way that I did it, I did create one object and then put it into the data structure and on a loop, and so just keep doing that over and over. Create one and put it in, create one and put it in. So is that making it biased, you're saying? That's making it...
Well, no, depending on how you generate the data.
So
the data is sequential. When you generate it in sequential way and then you put it in, then it will be biased, right?
But so like in terms of the usernames, they were kind of just random strings. They weren't they weren't alphabetical or anything. Is that what you mean?
Right, exactly.
So I don't think they were alphabetical. They were just random strings.
That's fine.
I don't see how it could come out so unbalanced. Like
well, then when you do search, you cannot just search one.
No, not even the search part. I mean, so I understand what you're saying with averaging the different cases, but I mean,
Mhm.
generating the initial structures, my results were uneven. So like I'm looking at it now and it increases, but sometimes it decreases as I go from 10,000 to 20,000 to 100,000.
Yes, there are some fluctuation expected too,
I
because
mean,
depending on the random value you generated, and sometimes it gets so screwed up even by random, so you have to rebalance the tree, putting more efforts to rebalance the tree because the tree gets so biased.
because of the way that the tree works.
Because the tree has to be balanced all the time, right? Every
So
time
it's
you put
doing,
value.
okay. Maybe that's what it was, that
So
it's
that's fine. Whatever it is, that's fine.
gotcha. It's
So the
just
main thing is
yeah,
not including one piece of data. Is when you do search, you can also
right,
search
right.
for one username because that could be best case scenario, could be worst case scenario. So that will fluctuate a lot once the tree is built, right?
That makes sense now. So yeah, I
Mhm.
gotta look at that. So
Mhm.
okay, so just I think that answers my question, that
Mhm.
sometimes just the creating the tree is it changes
Yes, because
by
again,
a
the
little bit.
data, right?
But I was just thinking like that's the way the computer works. Like sometimes it just is a little
No,
more faster
it is possible too. Yes, there is such a factor. Actually, that's
because
true. Because at
the
the
times are
moment,
so small.
yeah. Also, say when you are doing, okay, this is something else. I think I have to emphasize. I overlooked. When you are inserting data, right? When you're inserting data, make sure when you're inserting different batches of data to the data structure, say 10,000, 20,000, right? You do it while the computer is not doing anything else. So in other words, the computer should have no extra workload when you're doing one insertion versus another one.
Like
So
running other programs.
yeah, no other programs running. You're not listening to music. You're not watching YouTube. You're not in doing Photoshop and doing video editing when you're inserting the 2000. But when you insert in the 3000, you don't, you're not doing those. So you have to keep the workload of the computer a consistent way, because after all, you have one processor or four processors, right? If you're doing a lot of things at the same time, and then that moment, the computer will be slower in doing the insertion you are doing at that moment, right? Because it's busy doing something else as well. So it will take longer. Because a computer is always multitasking, correct? You understand that? The
Yeah,
hardware is always multitasking. You're running many applications. If you do it at the same time, if you keep, say, 20 applications, then at the same time of same kind of workload, 20 applications, same 20 applications, you do inserting 10,000, inserting 20,000, inserting 30,000, 40,000, same workload. In other words, the same computer, same environment, right? If when you are doing, say, 20,000, inserting 20,000, or search a data structure with only 20,000 in there, at that moment, you are doing Photoshop, watching video editing. Of course, it's going to take longer to do search. Even the data size is small. Does that make sense? Because the computer is too busy at that moment. It's multitasking with other things, right? So you have to control the environment.
that's
Does that make
something to
sense?
consider. Yeah.
Okay, you understood, right? I don't know if I explained this correctly or clearly.
Yeah, background programs and just there's
Right,
always what
right. So you have to keep it consistent, in other words, right? It doesn't matter how many, could it be 100 background applications or 1,000? You just have to keep all the 1,000 running for all the cases. Same background, like workload. Then the
well
result will make sense, right?
well there's always background processes going,
Always,
so you
always.
can't shut
You just
everything
have
off
to keep
maybe.
it consistent, the same.
Gotcha.
Always, right? And you cannot change computer either, right? You cannot say, I'm going to use my laptop to search for 10,000 and then use my, more powerful desktop with a much more memory, much faster CPU to do 20,000. When you do that, the 20,000 will take less time because the computer is more powerful, right? Obviously, it will take less time. Even the data set is bigger, right? Then the result come out will be funny, correct? I don't know. You guys look puzzled. Do you understand what I'm saying? Yeah. So that's how you have to evaluate given the same environment, same consistent environment to do it. Okay. So that's that. Okay. Now those are all these are the different data structures you can contemplate, right? When you do the initial discussion, you're gonna think about the tree maps, the tree sets, hash maps, the hash sets, linked lists, queues, and the stacks, right? Those are things arrays, of course, array lists and and those, right? You could also think about those. So those are things you can contemplate. Then you need to understand that anything with a hash in it is based on hash table, right? Regardless the hash map or hash set, is based on hash table. That means it's array based. Okay, it's array based. So if it's array based, then that means you have to know how big the array size is before you create the array. Okay, which for the most part is not what we want, right? Because we said we don't know. Correct? Okay. Now tree map, tree sets. Tree map has a key value pair. Yes. And tree sets has no key value pair. Okay. Now tree map uses a key, has to be unique. Okay. Now I saw some of you did this. Use the tree map. Understood no point to use hash. Okay, then some of you decide to use a tree map. Some of you decide to test the tree sets. Fine. Okay, there's nothing wrong with that. Okay. Now the further discussion shows that some of you say, okay, I'm gonna do tree map for my profiles and trails, right? To store trails and the profiles. Fine, nothing wrong with that. And then it's easy to understand why could it be a good choice to use that for a tree map, to use that for a user profile, because user profile is a unique user name, right? Right? If you cannot even find the user name, of course, there's no such user, right? Because we know user name is unique, correct? So that's fine. That's a legitimate claim. Now, some of you try to use a tree map for trails. Okay, that means now you will have a key. You need a key, correct? Because any map has a key, correct? So the key. So, but then people are debating what you use for a key as a tree, for trails. Some use the trail name because trail name is unique. But I think I said that trail name is not always unique, right? For example, there were 3 Long Island Greenbelt trails. They're all called Greenbelt. Okay, so that means it may not be a good choice to use the trail name, correct? If you cannot guarantee them to be unique. Yes? Okay. Then people say, okay, I'm going to generate a unique ID. So every time when you create a trail, I'm going to generate a unique ID, right? Like we use that ID to be the key. Makes sense, correct? It makes good sense. It's like what we did with like a user ID, use the person ID, and it's kind of like a textbook ISBN number because we know they are unique, right? So that would be a good candidate to use as a key, correct? Then everything else about the trail can go into an object and as value. Does that make sense? Right, right. So now you have a unique ID. You can even generate ID. Excuse me. Oh my God, my phone forgot to turn it off. Sorry. Okay, now, now you can create a trail ID every time when you create a trail object, right? You can do this like what we did, like increment, like a static ID counter, right? So every time you create a general unique ID, now you generate a tree map, and with the ID as a key, and then the rest in a trail object as a value. Okay. Now, what is the big O for that? Think about it. What's the big O for that? That's my real question. What do you think? Without doing any testing, without any coding, timing. So what is the ID? When you have a tree map and the key are unique, like sequential even, if you like, sequential. So first trail, second trail, third trail, so on and so forth. So what is the big O?
For searching, it would be 1.
Oh, give me 1 second. Give me 1 second. Sorry. So so searching will be 1, right? That's what Tim said. And many people thought that way too. Is that correct? Is that correct? Kiefer, what do you think?
Searching a tree map would be login.
Yes. Any kind of a tree is login. You don't get 1. And also think further. Every key is unique anyway. For any kind of tree map, the key is always unique. So it doesn't make your tree map unique or make your tree map a better tree map by having an ID. It's still as same as everybody else's tree map. The big O is login. Tim, are you convinced or you are not? A tree map is always login. Only time you have 1 is when?
In a race.
In a race. When you have 1 to do a search, when you have 1, what data structure gives you 1?
Hash map.
Hash map, exactly. Hashing map that give you 1 is exactly why is 1? Because it's based on
Array.
array, exactly, because the key is happens to be the index of the array. That's how you get into 1, right? That's how you get a 1 out from that. But a tree map, no matter what you do with the key, you can have it sequential, you can have it non-sequential. In fact, sequential make it worse. Why is that? Why you think a sequential key will make it worse?
because it's using binary search?
No. Why a sequential tree will make things worse? Say when you have key value pairs, right? And your keys are sequential, like 1, 2, 3, 4, 5, right? So you're gonna put the first key inside into the tree, and the second one, the third one, in such order. You will make this whole process even worse, slower. That's what I mean. So why you think that's the case?
You're basically incrementing the amount of times you go into either the left or the right. I forget the name. Like basically, you're making the tree unbalanced by making it you
Right.
go to the left always or to the right always.
Right, make it to the right because you're increasing, right, from 0 to 1 to 3
right,
to
yeah.
4. So you are just putting everything to be the right child, and every time you have to rebalance and rebalance to the worst case, the worst possible, because you are building from basically like a one-dimensional linked list into a two-dimensional tree. So every time you have to rebalance. That's why it's worse, right? Does it make sense? So, but always remember a tree, anything is log n. So you don't have one. Okay, log n. Good. Okay, now tree set. What's the big O? A tree set
Log n.
is still log n because it's a tree, right? It's a tree. Tree is always log n. It's a two-dimensional versus a linked list is one-dimensional. So both tree maps and the tree sets are log n, right? So there's no obvious reason that you can eliminate one from the other. So the argument you make saying, oh, the tree maps should be faster because I have unique sequential keys, right? So I should consider that to be my hypothesis, to be the right choice, right? And then when you find out that that's not the case, then you decide, okay, that's actually not one, is what you think. Then tree says actually is faster. Okay, so you're gonna have to, you cannot really make that a claim. In other words, both are log n. So your job is to find out which one is more efficient, given the case that both are log n. Yes? Okay, so your hypothesis cannot claim that tree map should be one, right? Because it's a tree after all. Okay, so Jalil, you have a question?
No, I was gonna ask if that correlates to the first problem in which it fluctuates in the graph when you display the graph, if because the tree is unbalanced, it also reflects that the graph is gonna show that you have one higher and lower than the other value when you insert 10,000 and then 20,000. Does that reflect in that way as well because the tree is unbalanced? If
Yeah,
you
we talked
understand
about that. That's when Tim asked that when you insert the random data, even that you could mess the time and then may not give you a perfect a curve, right? But we don't really care about that. What we care the most is searching. Also emphasize in your discussion, searching is more frequent operation than insertion and deletion, correct?
yeah.
Because everybody does search. When you log in, every time you have to do a search, and only when you create a user account, you do a insertion. Every time, only when you delete the account, you do the removal, right? So you have to put more emphasis on searching. So in your discussion, introduction part of your discussion, you should put more weight onto searching, right? Rather than insertion and removal in this case, right? So if you could do searching alone, That would be great, right? If you make the argument saying, hey, I think when we decide what data structure to use, more emphasis should be put on to searching, because that's the most frequent predominant operation, right? So when you make a decision, draw your conclusions, even do your calculations, your focus should be on searching, right, rather than insertion and deletion. Does it make sense? I'm discussing this. It's not saying that you have to exactly do what I do, but I think at least I want to tell you what I think it should be. And so I want to expose you to just my idea, right? I don't want to be required to do the way I did, right? Or the way I think. I'm just kind of expose you that this is how you think about the problems, right? And don't rush to coding. We use a different course now. It's not 148. It's not about the syntax anymore. It's about how to think about a problem, how to solve a problem, design a solution. That's the emphasis of this course, not coding. Some of you had a perfect application worked out using things we never talked about, right? And then I don't think you did it, to be honest with you. You probably just give this to someone and someone did it for you, or you pay someone did it for you. Because that's not what we want. You must have just give this thing to someone, pay someone, say, okay, do this assignment for me without telling the person what exactly the point. And you think if it works, then that's all we need. No, that's not what we need. Comprende? Okay, so I think, okay. Another thing I look at you guys is when you talk about linked list, many of you decided you could use linked list for history, right? Because the important part of history is the order. An order is not maintained in hash map or hash sets or tree map, tree sets, because they will be balanced and they will be hashed and so on and so forth, right? So you lose all the ordering information. So linked list is a good choice. Then the debate becomes, should I use a linked list or use a queue or stack? Okay, now I can tell you this. Queues and stacks are meant to be like programming tools. Like when you do undo and backtrack and that kind of thing, it's not really meant to be used to store your data. Okay, what does that mean? Now, you notice queues and stacks are a special case of a linked list. If you want to grow, right? It's a special case. What's special about a queue and a stack is they allow either one end of access of the array or the linked list, either the front end or the rear end, right? Or both ends in the case of queues. One to remove, one to add. Do you know what I'm talking about? Because when you talk about queue, you remove from the front, you add from the rear, right? Okay, you're not supposed to do anything in the middle. Like searching is never a purpose of a queue. Can you see that? Searching is not a purpose of queue. Queue is to remove the front, insert from the end. It's like doing big O of 1. Right? That's efficiency. That's what we emphasize. We don't use a queue to search through the queue and find the right piece of data, match the key or match the key you're looking for. That's not the purpose of a queue. Right? Queue provides big O of 1 for both the front and the rear. And the stack, though, provides big O of 1 just for one end, either the front or the rear, right? Because the push and the pop is all going from same end. Yes? So you could implement queues and the stacks using linked lists as an underlying data structure. right? Because remember, queues and stacks are ADTs, abstract data types. So the underlying data structure in this case could be linked list, right? Because you can grow, you can expand, right? So because of that, you will never use a queue to do search because it's not meant for that kind of operation. So we just use linked list instead, because linked list you can do search, yes, but nobody uses a queue to do search. If we remember what we did when we were learning, we were taking CSE 218, when we implement a queue, we never had a method called a search in the queue. When we do stack, we have pop and push, right? When we did the queues, we had remove and add, but we never really had a search because that's not meant for searching going through the queue, right? So linked list will be the one to do because that allows you to search, and the API has a method called contains. Yes. All right. So I think that's all. I think I talked about the unique ID in a tree map is not going to change anything. It's going to still be login. Okay, I talked about that, and also I talked about hash map and hash sets are still array based. Okay, so don't forget that fact that hash maps and hash sets are hash table based. Okay, and which is array based. So array is not the right solution for our project because you cannot expand. You're gonna have to rehash when you try to expand the hash table to put into a hash map or hash sets. So that's not a good solution. All right, so I wrote a few other things and oh, okay. When you I received some of your invitation to join the GitHub account, right? Okay, so I joined, accepted the invitation, join whoever I received from. Okay, so if you don't see me as a collaborator, then that means I didn't get your invitation because I did accept whatever I received. Okay, that's one thing. Number two, in your README file, please put down your name at least. If you use your GitHub account with some funny things that I cannot tell, it's not obvious to me. If it's obvious, fine. I know who you are. Okay, but if your GitHub account is like, something like a Mickey Mouse, okay, and there's no way I know who Mickey Mouse is. So I would go to README file. At least in the README file, you say, "Oh, Mickey Mouse is actually me and John Doe." You follow me? All right. So please help me by identifying yourself. Good. All right. But if you do use your, with your last name, especially in your username, then of course I can tell, and then I don't need you to do that. But otherwise, please identify yourself. Okay. Good. What else? Oh yeah, there are people using priority queue to store history. Okay, that's not a good choice because priority queue messes up the order, right? Because it's based on priority now. Unless your priority is days, then there's really no point. That's just extra work to create a priority queue. So use a linked list, and then that be fine. You don't need a priority queue to try to reorder everything, all the history entries. I think that's all before. So any questions regarding this? Any questions?
So are we gonna get our grades for this, or did you say
I
we're?
can give you grades back and I can put it on there, but I just want you to understand this. But also, I would like to give you the other people a chance to actually do something, maybe hand in something. Yeah? Should I just cut it out and move on? Or are you motivated to actually do something? Because there's nothing. When you submit, you don't submit anything, then it's a 0.
Yeah, I'm open to yeah, that makes sense if people want to add to the stuff. But I feel like I wanted to see what, because I feel like for the discussion, I know I didn't meet the requirements that you said here, like for the 6 points. So I'll definitely redo that. But I feel like for the implementation,
Can you guys do that then? Can you guys help me out? Try to rewrite your or write your discussion at least. Okay, because only very few people wrote discussion. I was so surprised, right? Because that's the whole purpose of this project. It's not just to finish a project, finish a program. Is to discuss the data structure to use. Okay. Now, if you have no clue how to do this, I gave a I gave a a template, I think, right? And I think that was something you can use as a well, look. So I was looking at this. I think when we did a 248, 218, where's my 248? Where's the 248? Okay, maybe it's over here. I was reading your comments and stuff, and then I had to copy paste into Word in order to read because the text file in Eclipse just let you go in one line. So somebody just wrote the whole discussion in one line. So it's hard for me to read that way. So I just copy paste, put into Word to see it. Excuse me. I thought we did one. Did we? Where was it?
This is
No, this
218.
is. ah,
It's alright.
so 240, 20. No, it's not there. No, not that. Oh, I did put in there though. I think I put in there. I moved in there to upload into GitHub to show you how to put in the GitHub. So that can be used as a like a starting point if you have no clue how to do this. Oh, I didn't import anything. That's what I was trying to make a video. Okay, so I'm gonna do this. I'm gonna do course repos 2020 CSE 248. This is the one we've been doing in class. No, what happened? I lost everything? I don't think so.
Isn't it maybe the one that's called phase 1?
Is it there? No, that's in downloads. No, that's someone else. I was checking someone else's. Surprised. There's nothing here. Alright, let me see. Checking everybody's stuff. Checking everybody's project. This is documents and repo. No, that's the wrong one. For 2020. That's why I went to the wrong place. Okay. So switch workspace for 2020. Okay, for 2020. This is the right one. I'm sure this is the right one. Okay, here is project 1, right? Here's the source. Yeah. So this is the starting. Let me close this. This is the starting point, project 1, that has a bunch of packages, right? Here is one you're going to generate the data sets, to put in the data structures. And these are, I did one, I think, I forgot, I think it's a tree set I did. Yeah, so I did that. And you can use, I think who said that was a Kiefer, I think. I could be wrong though. You could use stream for hash map as well, or tree map as well. Okay, not just the tree set. You can use a stream for tree map if you want to. Okay, there's a similar things you can do. So that's a starting point, basically, how you can evaluate things. And then here's what you use the generator random data, and then you can run them in here to put the data inside the data structures to decide. And then you're going to write a discussion and a conclusion here. I think it's hard to write it on as a text file in Eclipse. I think it'd be better if you write it on Word or some kind of text editor, and then format it, and then copy paste into here. Okay, so I saw somebody write the whole discussion in one line. I will go from here all the way to the right, and I have to scroll all the way to read that. So try to divide into paragraphs, and then if you could, try to use topic sentence. I don't know if you know what that is. Do you know what a topic sentence is? No? I know, right? That's not expected. So when you write paragraphs, right? The first sentence or the last sentence, try to tell the readers what that paragraph is about. And then the topic sentence should be short and sweet. Okay, so people can get the point easily. Okay, all the expansion, all the elaboration should be after the topic sentence. You heard of that sentence, that idea, that the topic sentence, that term, right? So when you write a paragraph, the first sentence, sometimes the last one, try to make it a topic sentence. Be better the first one if possible, and then the last one you should come back to kind of like a summary, and then reaffirm the point you make in that paragraph, if the paragraph is long enough. Right? In other words, if the paragraph is long, then the first sentence talks about what this paragraph is about, what a point you're trying to make. And then if it's long, the last sentence should reaffirm, rephrase what the point of this paragraph. Okay, so that's how you write. Okay, that's just, I'm asking a lot. I'm asking a lot. So So if you don't do it, I understand, right? But try to understand this is such a concept. Okay. And then try to put into paragraphs, try to divide, into points. Don't mix points into same paragraph. Each paragraph should make 1 point. Don't try to make multiple points in one paragraph. You learned that, right? You must have learned that in ENG 101 or, right, English composition. You should have learned that. So try to make use of that, okay? Good. So if you didn't write the discussion, the conclusion, please write one. If you did write, and you may want to rewrite it, okay? You can rewrite it, and then I will give you some extra time for all of you to improve this or starting doing this project. If you never done anything, you never did any before. Okay, so how much time you need? Another week? Is that enough time? For those who have you never done any, you haven't even started. Is a whole week enough?
Yeah, that's enough time.
What
Yeah, I think that's enough time.
about other people? Because basically, like half of you didn't do anything. Some didn't even submit, some submitted a hello world. What is going on? 1 week? Is that enough overall? Don't give me a product, right? Don't give me a complete product like the app, the application. I don't want that. I want you to discuss what the right data structures to use. That's all I need. Right? Whatever data structure you use, you should justify, in other words. Don't just give me a complete product with an array or array list and show that the program works. That defeats the purpose. Is 1 week good? Yes? Okay. So now I checked every one of your work. So if you want to talk about it individually, you could email me so we can talk about your project individually. Okay. But if you had someone else did the project for you, okay, please don't do that. Don't waste your money. Okay, if you pay the money, or don't waste the favor. Right? Redo it. Have another week. Do it the right way. Okay. Because the classes are not about coding. Coding is the last thing you want to do. We want to do in the end. It's all about designing, about thinking, about decision making. So code has no weight right now, at least. In the end, yes, but not now. Is it okay, Chris? You seem tired. Don't give up, guys. Don't give up. It's the end. Don't give up. Keep up, okay? Keep up the work. Don't give up. It's a shame to give up at this time after all the semester's hard work. Is there anything I can do to help you this moment? Just read this thing. Read the code I wrote. If you don't understand, maybe you should make a point with me so I can go over with you individually or in small group. We can do that. Those of you who didn't hand in, especially, you have no clue what's going on. You may need another meeting with me so I can explain to you what I need from you. Okay, good. Anything else?
Yes, just so I can clarify what you're giving us a week on.
Right, I thought a week, but I really want you to do it, right? I mean, I've been giving out a week and a week and a week, and the only reason is I don't want to really see you next semester unless you really force me. Okay, I don't.
So,
It's not like I don't like you. I like you guys, but not
so
about.
we would have that week, and we would because I got a couple of points. I made a priority queue for user history,
Right.
so I'll change that. I need to shore up the discussion, and I need to work on my find methods. So
Right.
if I do that, I'll just ship the project
Submit
back to
again.
you.
Submit
the whole thing again.
into Dropbox again, and now you should start using your GitHub. I don't think I have time to. Probably I do, if we don't have much more further discussion. So redo whatever you want to redo, improve whatever you want to improve, or start working on the project now. Then you have a week to hand in. I could give you 2 weeks, but that's really not good. I think it's not good. I'm just bending myself backward. I hope you see, it's really I try to accommodate you guys, but I don't want this whole thing becomes just like a game. You don't really care at all. Yeah.
For the discussions part, how much do you want pretty much each package or each class to have a certain discussion, or pretty much anytime we implement some type of data structure?
No. It's not about implementation of your application. Gregory, I think you got it completely wrong. It's not like when you use array, you justify why you use array. It's about what data structure you use. That's the whole goal. I don't want a comprehensive, complete implementation of this project. I just want you to assess, evaluate what data structure to use the most efficient for the most efficient operation, like a search. Okay, for this project. So the implementation is way down. It's like the end of the semester thing. So your code is about assessing data structures, not about implementing this program so people can enter username, password, log in, none of that.
Okay, because when I was first doing it, I pretty much just implemented everything because I honestly thought that's what we were really supposed to be doing. 'Cause if that's supposed to be later down the line, I'm still pretty happy with it because that at least means I have it. But
I just hope you didn't waste much money on that, Gregory.
no, I didn't use any money. No, I have one of my friends was able to just give me some pointers on everything. Cause with the streaming and with the new this was using stream and everything, I wasn't really confident in that. So I just asked one of my friends how to implement that better.
You don't have to use stream if you don't need to. I mean, just make it more concise. Okay, you don't have to. But the point is, the whole approach you did was completely wrong.
Okay.
If you read the description, it's deciding the right data structure for the 3 data types: trails, user profiles, and history. It's not like a complete program. You can enter stuff, you can run stuff. It's not.
Okay. So
you have one discussion, and then to the code you put in is just meant for this part, for the approach and the methods.
Okay.
That's the one part of your whole. The real purpose is the whole thing. The code is just to constitute like a part 3.
Okay.
To generate the data, generate results. I mean. Okay, then you're gonna have to discuss and what the data structure to use for each data type. For username, for user account, user profile, for trails, and for history.
Okay, so what alterations would I have to make with mine? Because if I did mine
You're
completely
gonna have to
wrong, then
redo the whole thing.
oh my god! All right,
Well, as I told you, we explained this. You have to pay attention, Gregory, in class. So like the whole day today, when I explain things, you were not listening. I don't know what you were talking to someone else, or you're not listening. So anyone tape recording this at all? I think so, right? I think Nick, are you recording this, Nick? Yeah,
Yeah, someone's
Nick
got a
is doing
YouTube channel.
very nice. So yeah, so Gregory, I think you probably want to watch the record.
okay. Because honestly, I was just confident that I did it right, so I was like, okay, he's
No,
just
no, no.
he's just redoing it.
From the first sentence, I told you that's not right. It's not implementation of
Yeah,
this
honestly,
project.
I thought that's what it was. So okay, my bad.
No, 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 no. So I worried about it when I was reading your project. I said, how much money you spend on this?
No, I didn't spend any money on it. That was
You
still
didn't
me.
spend any money?
That was still me. That was not me spending any money on that.
Okay, other questions? No? No other questions? Okay. If no other questions, see if we can quickly show you. Many of you did this the thing already. Okay, so I'm going to show you how to link a local project, a local repository to a remote repository on GitHub. Okay, when you already have an existing one. Okay, so I'm going to do this. I was trying to tape it. Maybe I should. Let me see how I'm going to do this. Okay. Okay, I have a portfolio 2020, right? So I'm going to start from scratch, and let me see if I can delete this all from here. So that's why I may not have enough time. Let me go to change switch workspace, go to portfolio hike app. Okay, so so I have a app, right? So I'm going to delete this. Why don't I delete this? Oh, it's not imported. Actually, it's good. Okay, good. So it's not even imported. I don't even have to delete. So I'm going to exit this out. And then I'm going to clear up that whole folder. Okay, so I don't need that. Go back to documents. I'm going to delete the portfolio 2020, start from scratch. Okay, I'm going to do it, try to be quick so we can finish this. I'm going to delete this. Okay, so I delete, I have nothing, right? So I'm going to create a new folder. So anywhere I can right click, create a new folder. I'm going to call this portfolio 2020. Okay, so just create an empty folder. And then there you go. So once I've created a folder, I'm going to use this folder as my workspace. I'm going to use this as a workspace. Okay, in other words, my project is going to go in here, right? So I can do things like this. I can start my Eclipse. Okay, I'm going to go to Eclipse. All right, so I'm going to use that portfolio 2020 as my workspace, right, which I just created. Yes. Okay, so when I launch this, you will see there's no project inside. Okay, there's nothing in here. It's empty because it's a new folder I just created, right? Okay, so you see there's nothing here. There's no project at all, right? So now I'm going to import the project that I did before. Like you guys worked on you put in somewhere else, right? When you did your project. So I'm going to import that. Go to File, go to Import, and go to General, and existing project into Workspace. I'm going to look for that project we did before, which is in Documents, under Portfolio. Under Course Repos 2020. No, not this one. Course for 2020. So in here, you see there is a CSE 248, right? And then there are a bunch of projects, right? So I'm going to select that folder. Okay, CSE 248. And then you see a bunch of them, but the only one I want to move over to put into repository is the one that says project 1, I think. See the project 1? So unselect everything, just select the project 1. So in other words, I'm going to move this from this old location into my portfolio 2020. Okay, so now just say copy project into that workspace. That's important here. Copy projects into that workspace. Okay, so let's say finish. Now this is in the workspace, portfolio 2020. It was empty, now there's something in there, okay? All right, so I'm going back to that location. You see the portfolio 2020 has project 1 inside, right? Okay, so I'm going to make this a local repository, okay, using Git, a local repository. So whatever I do on my Eclipse will be backed up here, okay? So I go to Git bash, you see Git bash, okay? And then I'm going to go to that folder, cd documents, and then portfolio 2020. Okay, you see that? So that's my workspace. Okay, you can already see there is a project 1 in there because I did the import earlier, right? Okay, now I'm going to make this a local repository by doing git init, right? Okay. Now you can do init. You can just say, if you just hit enter, then the whole workspace will be a local repository. But I want to do just project 1. See if we can do just project 1. Okay, now my project 1 is a local repository now. Okay, my project 1 is a local repository. Okay, good. Okay, now I can even do git I can see ls-a, and you will see that the project 1. So cd project 1. I just go into project 1. It's a bad name really because now every time I have to use a double quote to get in there. So now I'm in project 1. Okay, so you notice this is called a master. Let me make this wider. Okay, this is a master branch. You see that, that master branch here, and it used to be the same on GitHub. Okay, but then GitHub decided the 1st of October to change that to main branch, so I cannot match anymore. That's why we had the trouble last time. Okay, good. All right. So now I'm going to stage or follow all the files in this folder. That called stage. So if I do git status, you can see there's all this unfollowed, untracked. You see this? This I just imported earlier. Okay. So in order to take a snapshot, the first thing you have to do is you have to stage it, right? By doing git add, then dot. Okay, git and dot. Okay. Now I already have a git ignore in there, but if you want to have a readme, you can actually add one. You can also add a .git ignore if you want to. So if I want to add a readme, just say vi, or use any text editor you want. Just make sure you save it in that project 1 folder. You need 2 files usually. One's readme, one's .git ignore. Okay, so if I want to do a quick readme, so I just readme.md. Okay, so I create a new one. Right now, there's nothing, right? I hit I, so enter. So I'm going to say £1, and this is £1. You see that? Then space, I would say hiking project. Okay, and then you can say £2. That's the header, right? Okay, I need to put it down here. Oh, sorry. And then this is by John Doe. Okay, so you identify yourself, or you have a to-do list, whatever you want. So that's readme. Okay, and then you put a date, the version number, the author name, whatever you want. So when you're done, you just make sure you save it, write and then quit, and now you have that file. So you do ls, and you see you have a readme. You have a data results, you have a bin, you have a src. So you can also do a vi dot git ignore. Remember that dot ignore? Okay, and then make sure you notice that ignore starts with a lowercase I. Okay, hit enter. So I have something that's ignored, like a bin is ignored. I don't want to, so I can I can delete that first. Okay, and dd. So I delete that. I can just say I. So now insertion mode, I put a star and then put anything dot class. So class will, anything class will be ignored. And so that includes all this java.class file, right? Anything that's related to temp. So put a star dot temp. So that will be ignored as well. Then just temp, anything with a folder will be ignored as well. So those will not be backed up. So we talked about this before. So now I'm going to just say escape back into command mode, then save and quit WQ. So I have both files now. So ls l-a will show you those are new files, all the files I have, including the hidden ones. But also notice .git. You cannot see my cursor, can you? Can you see my cursor? Okay, you see that .git? That's a local repository, okay? But right now, there's nothing. So all I have to do is git status, and you see all those things are new. They're not staged yet, not tracked yet. So I just say stat git add dot period. That means I'm going to track or stage everyone in this project folder, everybody. Okay, so hit enter. Now they're all tracked. You will do git a status. You will see they say, oh, these are tracked, and then you just, oh, I misspelled status. And then say, oh, these the color is green. They say, oh, they're tracked, but they're not committed yet. Okay, now the next step is commit, right? So git commit -m, and then you're gonna say my initial commit. Okay, so that's your first commit. You hit enter. Now they're all committed. They went to the local repository so far. Okay, and there's nothing to do with the remote. Don't forget that. There's nothing to do with the remote yet. Now I'm gonna have to go to the remote, create a remote repository so I can link. Okay, now again, notice this is a master, okay? Don't forget that, okay? Because we're gonna have to rename it into main to match the one on GitHub. That was the reason we had a trouble with. Okay, now I'm going back to my browser. Okay, I'm gonna show you on my browser, and then I go to github.com. Okay, I'm gonna create a repository here. I'm going to create one. Just go to new. You see new. Okay. And then I'm going to call this repository hiking app for 2020. Fine. So that's just the name of the repository. Now, this is a remote repository, though. You understand it? Okay. This is on GitHub, right? Okay. So I can make it a public. I make it a private. Doesn't really matter. For your sake, you should make it a private. Never make it public, because you will see how many people are trying to copy from you to get a free copy rather than pay someone doing it. Okay. Now you don't need to add readme, add .ignore because we're going to push the 2 from the local up here. So you don't need another set. Okay. So and you just say create repository. Okay. So now a repository will be created, and you will see this is the instruction, right? Because I didn't notice at that time. You see, you have to rename. There's a place called branch -m main. That statement I didn't do last time because I didn't know they changed the name. So this is the default. The branch is called main now, no longer master. Okay, that was the reason. Okay, good. So far so good. I know it's late, and so I try to do it quickly. So if you do have a question, just let me know. Okay. Good. So I'm done with this. And now the most important thing you have to remember is this is the place you need to connect it to. That identifies this repository, right? So we're going to copy this because we need to paste it later, okay? Or you can just type it. It's pretty easy to remember. It's first of all, make sure it's HTTPS. Okay, it's encrypted version. And then you have github.com, then you have the username, then you have the application repository name, then remember .git in the end. Okay, so always finish with .git. Okay, good. So what's good? Yeah. All right. So I'm back to my Git bash. Okay, here. I'm going to make the connection now, right, between my local and my my remote. Okay. So let me see if I can show you this before I move away. So what we did is this means create a README file, which you already did. So the instruction is kind of from beginning, which we did some of it already. We create a README file. That's how you create it by using a command called echo. We did make it a local repository by going git init. So we did that as well. And we created a README file as well. You see this? We tracked it actually. Now we made our first commit, right? We did all that. So the only thing left to do is to name our branch from master to main. Okay, now we're gonna do that. Okay, so we're gonna go to my git branch, right? So I say git branch -m is capital M. That means false. If there's such a branch, override it. Okay, so we're gonna call that a main. Okay, remember this is the master right now. You see this? When I hit enter, this will change to main. It will change to main. Okay, hit enter. Now you see the main. That was the reason. I never thought that they are so progressive. Okay, I never thought GitHub is so progressive. I just underestimated them. Okay, so now we made this. Now we just have to do the mapping now. Okay, here's how you map it. Git. Okay, it's always git remote. You want to set up a remote repository to link to, basically. Okay, in the future, that repository is going to be called remote. Okay, that repository we created earlier. Remember that? That's called hacking app. That's the remote. And then we're going to add one. See, it's kind of awkward to use add, right? And we're going to call that a main, which is going to be main anyway. So we identify, we're going to map our main to its main on remote on GitHub. So what's it good? Git remote means we're going to call that place remote in the future rather than local, right? And then add means we're going to add a new connection. Then main means we're going to map to the main branch over there. That's the only branch. Okay, so we're going to map to the main. And then now we just have to give that location. Remember that location? It's a HTTPS :// right? github.com/Chen the instructor. That's my user account, right? Then I have to say that's called hiking application, I guess. Hiking app for 2020.git, okay? Hiking app for 2020. So that's the one you want to use. So you have to match it up. So hiking app for 2020.git. Don't forget that .git. Okay, good. All right, now I'm gonna hit enter. No complaints, that's good, right? Okay, so now we are ready to push our local repository, local snapshot to that remote location, okay? Now, what if you made a mistake? If you made a mistake, it won't work. Like last time I made a mistake, right? So it doesn't work. And so what you have to do is you have to do this: git remove, remote, remove, then origin. No, main or whatever you call that branch. No. I made a mistake. I made a mistake already. This should be called origin, not main. Origin. My bad. It's called origin. So I made a mistake. So it's not going to work. So what I'm going to do is I'm going to remove that origin. Actually, it's a good thing. Made a mistake. So I'm going to remove that remote. I call the main, right? So I'm going to call main. I'm going to remove that main. Instead, I want to call the origin, actually. My bad. Okay, so I'm going to hit enter. And now that's removed, okay? That's removed. Now I'm going to redo this whole thing. I'm going to say, I'm going to do this. And now this one, I want to go all the way here. I'm going to change this to origin, okay? And now I'm going to show you that line on that site, on that page. There you go. And you see the origin? I got so confused with the main and the master. Okay, now that's the correct one. That's the correct one, okay? So you cannot just change it without removing first. So make sure you remove first, okay? Now, once you've done that, the other thing you have to do is just the push. You see the push? Okay, now go back here. Okay, now I'm gonna hit enter now. Okay, so hit enter. Now I did that. Okay, now I just say git push dash u. Okay, then you put it down origin main. So you want to push your stuff, local repository, to the origin, which is remote. In other words, origin is a name for the remote location. That's a convention we all call it origin. Okay, they came from the idea we pull clone before. The first time we clone, everything came from there, right? But now we don't do clone. We still call that origin. Okay, now we're going to push our main branch to the origin, which means the remote. That's how they make a connection. And to its main branch. That's why you need to put the main here. You hit enter, and then hopefully it will just go through. If it doesn't go through, maybe that means you may had a typo here, but it did go through, right? New branch is the main to main, and everything 100%, so it works. So now you can go back to check to the browser, and then you will go to your folder here, and you will see the stuff we did before, SRC. You see the history model, trail model, user model, util, and everything is here. And you can see even the commit, one commit we did, my initial commit, remember this one? That's the one, my initial commit, push it up as well. So now the connection's made. Now from this point on, you can push up there whenever you want. Okay, somebody taped it, recorded it. So he's going. I know Nick is a wonderful person. He's going to post the link to you guys for you guys to watch if you get lost and ask questions either on Piazza. You should really take advantage of this kind of building some communities. You can ask questions. So we don't want to lose half of you guys. And I don't have that many seats next semester for you. So, okay. All right. So I think that's what happened last time. I wasn't following that close enough. So it didn't work last time. But any questions? No? It's a long lesson. So, but hopefully you found this was useful. Yeah. So have a week. You do or start doing your project. Yes. Otherwise, you give me no choice. Okay, I have to apply to school and open another CSE 4248. I hate to do that. Okay, make sure you write discussion and conclusions. Okay, that's the main goal. Without that, you're not going to pass the course. Bueno, muy bueno. All right, adios.
Professor, you said that you were gonna upload the grades.
Upload what?
Upload the grades, or at least for this
Yeah,
assignment.
I can give you the grade. Yeah, but
Okay.
I think we should redo it. Everybody should redo it. Okay, just write it nicely, do a better job. Okay, but half of you guys have nothing, so that's easy to upload. Okay, but you understood my lecture though, right? So if you have a question, you should ask.
Yeah, I
Okay.
gotcha. I'll record them
Okay.
all anyway, but that's just for my
Yeah,
PC.
that's fine.
So,
That's fine.
alright, I'll email
We
you.
have it on the paper, so I just need to upload it for you. Okay. All right.
Yeah, I'll email you to find it out, or if I can do
Well,
anything
no,
better, I
I'll
should
upload
say.
it onto the Blackboard on the
Alright,
portal. Okay.
alright. Have a good day.
All right. Bye.